Hi, this is a design coming from Sri Lanka and my name is Visagan. So this is a design based off a blow-off valve. Hence, I have titled this as blow-off valve based non-electric ventilator. I am sharing my design ideas for an emergency ventilator while thinking of making one with whatever materials that can be locally sourced during the lockdown period. I came up with a couple of candidates, which are turbo blow-off valve based non-electric design, using parts scavenged from all printers to compress a bag ventilator or a plastic foot pump that comes with these gym balls and air mattresses. The third one would be using a vehicle tire air compressor in a ventilator design, as we have one compressor per car. From these three, the best approach would be to build the turbo blow-off valve based ventilator, as this would not require any additional power and every hospital has an oxygen line running near to the patient and with considerable pressure in those lines, which can be used in this design. I chose the name to be turbo blow-off valve because it can easily point you to the right direction, but any blow-off valve is okay. I also found that in home beer brewing, they use a device called spunding valve, which works on the same principle. You might ask, where is the device that I am talking about? Well, with the lockdown, I can't go out to source the parts, or from what I have at home, I can't make one. Also, from where I come from, it is hard to get some parts, but these are valid designs. So please share this and make use of any idea cues that you can find useful from this video. I did some search online on ventilators, and the two most thing that is important in a ventilator came up to be the tidal volume, which is a kind of pulse width of the airflow, and then the rate, which is the number of breaths per minute. I'm not a doctor, so I might not be knowing the exact terminologies, but this is what I found. In a medical ventilator, the tidal volume is calculated in milliliter per kilogram or cubic centimeter per kilogram. So this is the reason as to why we cannot use an off-the-shelf blow-off valve used in cars. But if you can find an adjustable turbo blow-off valve, then you can replace the spring inside to a different spring that has less tension, and this would be the easiest way to build this ventilator, where you can combine two of them stacked together to form a closed enclosure, and you have a ventilator immediately in your hands. But at the same time, it's not hard to make one. You just need a few springs, a piston, and a cylinder, which you can make from PVC tubes, medical injection syringes, or if you have access to industrial metal pipes used for plumbing. The design that you see now on the screen is based around blow-off valve principle. Let me give you a brief on the components in this cross section that you see, which are listed from top to bottom. Oxygen inlet from source, inlet pressure control knob, analog pressure gauge, piston, spring guide rod, which is to guide the spring movement, spring holder, which is attached to the bottom of the screw, and ideally it should be mounted on top of a bearing or a shaft or a roller, whatever you might call it. This way, turning the screw will not add additional rotation torque to the holder or spring. Outlet pressure control knob or screw, oxygen outlet port, and finally you have spring tension control threaded screw. The spring tension screw is used to control tidal volume, and the outlet pressure control knob is used for the rate control. We can attach an analog pressure gauge just before and just after the outlet pressure control knob to get the relevant readings. In this image, you can see that the valve is normally in closed position, and when we connect the oxygen inlet to the unit with controlled dispense rate by the inlet pressure control knob, The passage that you see from the inlet till the piston head would act as an expansion chamber, which I would call as chamber 1. And with time, the pressure inside this chamber 1 increases and starts to push the piston down. And when the pressure inside the chamber 1 is greater than the spring tension behind the piston, the valve eventually opens and the compressed air gets into the next chamber, which is chamber 2. And when the pressure inside chamber 1 falls below the tension of the spring, the piston automatically closes the chamber 1. This allows the pressure inside chamber 1 to build up again. During this time, the air expanded into the chamber 1 will find its way through the exit port through the rate at which we set on the outlet pressure control knob. This process will then be running continuously. I hope this helps in any way to build an emergency ventilator. While I was working on this setup, I found a video showing a ventilator working on a similar principle. But that video did not mention anything on how to get this or how this would work. But I am showing this here to prove the concept works. Thank you.
Guys, I just want to disclose I have no financial connection to this device. I just think it's really cool. All right, so this is, let's say all your ventilators, there's a mass casualty and there's 20 patients and all your ventilators are being used and you have nothing else. This is basically a portable ventilator. No big setup. Hooks up right here. This controls tidal volume. And then Leo, I have Leo, one of the respiratory therapists here. This controls your rate. And let's pretend this would be your pressure right here, right? And so this is your ET tube, intubated. And this is just kind of mimicking your patient's lungs right here, all by itself. No big ventilator. You could have 10 of these ready to go in case of a mass casualty. 30, 20 patients from a boat, from a disaster. I think it's really cool. And obviously it hooks up to high flow oxygen, which is hooked up straight to the tank.